All right. I want to do. Make that a little bigger. So remember the other day we started, it was kind of this, I went over to the Desmos that drew all my tangent lines for me. We found all the slopes of the tangent lines, and then we created a function from it that is essentially called the derivative function. So the derivative values create in and of themselves a new function. So we can talk about the function of the derivative as well. And we had this kind of relationship between the two. If the derivative is positive, the original is increasing. The derivative is negative, the original is decreasing. And if the derivative is 0, the original is constant. So that's essentially what we're going to do now, because the main point of section 2.2 is to kind of be able to kind of look at a derivative graph. Sorry, well, both ways, so even though I said it backwards this time. So essentially we're going to look at a graph, and we want to be able to pick out amongst some choices which one is possibly the derivative graph. And then we also might want to go backwards. If we're given the derivative graph, can we pick out the correct original graph? And that's going to be using that relationship between the two of the positive gives increasing, negative gives decreasing, and all that jazz. So got to remind myself what I want to write in these blanks. Say we wanted to determine the derivative graph from an original function. So we're given the original graph, and we want to pick out from a couple choices what the derivative graph's going to look like. Here's how we're going to do that. And why is this thing always here? Go away. Thank you. So the first thing you're going to do is you're going to locate the maximums and minimums of the function. You're going to just kind of point them out, and specifically you want to look for their x values. That's the thing you actually care about. At these points, the derivative is going to be equal to 0. Because if you think about what the derivative is a slope. So if you think about being at a maximum or a minimum point, people on Teams can't see me waving my arms around, at a maximum or a minimum point. So at a maximum, you have a tangent line on this side looking like that, which would have positive slope. And then on the other side, you have a tangent line that's now got negative slope. Well, at the top here, at this maximum, we essentially bottom out, if you will, and we get a tangent line that has a slope of 0. So that's why the derivative is 0 at those points. But anyway, so when I say the derivative is 0, the thing that's going to tell us about the graph is that it should either touch or possibly cross. So it doesn't need to cross, it just has to touch. But usually it crosses. Anyway, the x-axis. So we kind of locate these x values of the maxes and mins, and those are going to tell us where the derivative graph is going to touch the x-axis. That is usually, like 85% of the time, enough information already, but sometimes you need a little bit more. Because again, we're not trying to draw these from scratch, we're just trying to pick one out amongst a couple of choices. So if that's not enough information, what you're going to do is you're going to determine where the original function, thanks for answering that, Catherine, for Juliana. Determine where the function is increasing and where it is decreasing. So usually what I'll do is I'll kind of actually put some dotted lines on my original function, and I'll kind of write increasing, decreasing, increasing, or whatever, is going on there. The derivative is going to be positive and negative respectively in those intervals. Which is exactly that relationship that we have in the notes kind of that we took down on Monday. If the original function is increasing, the derivative is positive. If the original is decreasing, the derivative is negative. That's usually the most information we can really pull. So we don't really know what it's doing above or below the x-axis, usually we don't care because that is enough information for us to get the right choice. But if you need to look the tiniest bit further, which you usually don't, you can look at how steep the tangent line would be. So essentially those kind of lines that we were looking at Desmos the other day. And if you're trying to visualize what the tangent line looks like, let me scroll down the tiniest bit. If you have trouble trying to figure out what a tangent line would look like, say I wanted the tangent line for right here. Now remember, the tangent line only touches the function at that one point in that small interval. But if you're having a hard time visualizing them, kind of pretend that there's a point right next to it and draw a line between those 2 points. Putting that extra point on that function is not like an official, actual good thing to do, but it'll at least get you the general shape of that line for you to use for your brain, if that made any sense. But anyway, we can essentially look at how steep these slopes are, and that would tell us kind of the y value of the derivative. I know it sounds super wishy-washy, because it is slightly. But again, this part we usually don't need. We usually don't need kind of that extra bit of information. The other information we have before that is enough to pick the right choice. So before we forget about the things I just wrote down, I'm going to scroll past the next thing, and I'll come back to it before we do that example. But let's go down to some examples of this and see how this is actually going to work. Now, I know those answer choices got a little blurry, but really we can tell enough that we need from what we have. So the big one is the original function, and those little ones are our derivative choices. So what we're going to do, and again, I usually like to draw all over my original function. You want to locate the maximums and the minimums. Well, there's one, and there's one. I'm going to split the function up at those points. So we got about x equals -1 and x equals 2. Approximately. And then let me look and see what the original function is doing in kind of each section, and then I'll try to transfer that over to what the derivative would be doing. So my original function is decreasing in that leftmost portion. So since it's decreasing, I'm just going to write decreasing, well, abbreviated. And then this middle piece is increasing. And then I'm decreasing again. So what that means about the derivative, let me write it maybe in a different color, if it'll let me choose a different color. So for the derivative, kind of remind ourselves that the red means for the derivative. If the original is decreasing, my derivative is going to be negative. If the original is increasing, my derivative is going to be positive, and then negative. So now I got to kind of go over to my choices and try to figure it out. Now also remember that these two max and min points, the derivative graph should at least touch, if not cross, the x-axis at those points and only those points. I lied. There are very few opportunities where the derivative could also touch the x-axis. But okay, back up. Come back in. Max and min points of the original function. Your derivative is going to cross the x-axis at those points. It's only going to cross the x-axis at those points. It could possibly touch the x-axis at another point. Usually doesn't happen, but it could. But when you look at the max and min points, if the functions you're looking at cross more than that many times, you know that's not one of the options. It's only going to cross So in this case, this example, it's only going to cross the x-axis twice. It can't cross another time because I didn't have another max or a min. So out of those options, the first thing I want to look at is how many times do they cross the x-axis, and do they cross the x-axis in the right spots? Option A crosses the x-axis 3 times. That's out of the running. So that's kind of like the first thing you should look at. How many maxes or mins do you have? That'll tell you how many times it should cross the x-axis. If you have any that cross too many times, get rid of it. So we're kind of down between B and C. And in both cases, I know, again, it's a little blurry, but they do cross kind of both around -1 and around 2, which is where they should cross. If they crossed in completely different pieces, like if it crossed at -4 and 0, that's also another thing that you can say, okay, that one crosses in the wrong spots. So you can cross those off too. But now, essentially, so this is where we need kind of that extra bit of information of this negative, positive, negative thing. And Juliana, you're actually going to be right. So which one of these functions starts negative, crosses the x-axis to become positive, and then crosses the x-axis to become negative again? So below the x-axis, above the x-axis, below the x-axis. The only one that does that is part C. Option C. The other one is essentially backwards. It's positive, negative, positive. So this one would be not our option, and the answer would be C. Now, again, don't get bogged down about what it's doing above and below the x-axis. You just care that it's above or below the x-axis. You don't give a flying crap what it's doing as long as it's above or below the x-axis in the right spot. Does that make sense? So maybe just one more way to hit it home, hopefully. So this graph here is negative, positive, negative, whereas this one over here, which was not our answer, was positive, negative, positive, but I was looking for a negative, positive, negative, so the only one that matched was part C. I don't know why putting on my mask makes my nose so itchy. Does anyone else have that problem? Is it just me? All right, so let's go on to another one. Same idea. First thing, let's find the max and min points. And maybe I should be clear, when I say max and mins, like the endpoints here don't count. I mean like a complete max and a complete min, one that like changes direction. So that tells me that I've got to cross the x-axis at, you know, around x equals -3.5, around x equals 0, and around x equals 3.5. So let's start with that information. So I want to look at these graph options over here, and I want to look for one that crosses exactly 3 times and in those general vicinities. So this crosses twice. That ain't it. This crosses technically a 3rd time over there. I know it's kind of blurry. But if you look at this one, again, I know it's kind of blurry. I'm really sorry. If we kind of count, we've got 1, 2, 3, 4. This one crosses at about x equals -4, at about x equals 1, and about 1, 2, 3, 4, 5, x equals 6. That crosses in all the wrong spots. So that can't be it either. I'll also talk about something more in case you don't recognize that, or you think maybe it's close enough and you kept it in the running, which would be okay. And then we've got this one that crosses 3 times at approximately -3.5, approximately 0, and approximately 3.5. So that definitely, well, since we crossed the other 2 out, that definitely seems like our answer. But let me talk about it a tiny bit more. Say for you kept this in the running just for giggles, or maybe you just weren't sure, how would you then figure out which one of the it was? So again, that's when you would come back to the original function, excuse you, and say, well, we're decreasing we're increasing, decreasing, and increasing. So if we think about what that means for the derivative, we would need a derivative that's positive and then negative. Whoa, I've done it backwards, I've done it backwards, I've done it backwards, I've done it backwards, I've done it backwards. Negative, very sorry. And then positive, and then negative, and then positive. So below the x-axis, above the x-axis, below the x-axis, above the x-axis. B kind of follows that. It's below, above, below. But it never quite gets above for as much as we need it to be above. We need it to be above for like that last section of that graph. It's got only a little like teeny tiny bit, which isn't enough. So we know that that would also not be it. So then to triple check, well, this graph that we chose for our option starts below the x-axis, then goes above, then goes below, then goes above. And again, I don't give a flying crap what it's doing above or below the x-axis as long as it is above or below the x-axis. Make sense? I'm running out of time faster than I thought I would. We're going to do one more, and then I guess we will get the other direction on Friday, because we're out of time. So one more. Same idea. Where are my maxes and my mins? No, my color's changed. I never changed it back. So I've got to cross the x-axis at about, let's just say -3 for my sanity. And at, about 2 or 2.5. You don't have to be really perfect. Again, most of these kind of fall out just kind of from that. So I know that my graph has to cross the x-axis twice. It could touch more than that, but if it crosses more than twice, then I know it's out. First option, crosses more than twice. Yep. You want to include this too? So is that a max or a min? Nope. So don't. Yep. You only want to pull out the maxes and the mins. Option B, crosses 3 times. That's out. I didn't mean for all of these to be C, but they all turned out to be C. So this one only crosses twice in approximately the right areas. Let's triple check that it follows the correct pattern of above and below. So this was decreasing, increasing through this entire piece, and then decreasing. So we want something that's below the x-axis, above the x-axis, below the x-axis. Only option is option C. Because also, if you were to not have gotten it just from the crosses the x-axis piece, option A starts on the wrong side of the x-axis. I needed to start below the x-axis. Option A starts above the x-axis. That's not good. Option B does kind of follow it at first. It's below, above, and below, but then it's got an extra above piece. I don't want any extras. I need exactly what I have from the original function. Make sense? So I was hoping we were going to get to this one, which is just the kind of opposite way, but we'll talk about that on Friday and then hit 2-3. When in doubt, choose C. I guess. I didn't mean for it to happen, but it did. All right, so let me get these people off the main screen.